Hello. To finish the video on analyzing graphs from Chapter 5, we're going to talk about horizontal asymptotes. So for horizontal asymptotes can cross the line, cross the asymptote, if the degree of the largest exponent of the denominator is bigger than the degree of the numerator. The horizontal asymptote is the x-axis, y equals 0. If the degree of the numerator is bigger than the denominator, then there is no horizontal asymptote. If the degree of the numerator and denominator are the same, the horizontal asymptote equals the leading coefficient, the coefficient of the largest exponent, or of the numerator divided by the leading coefficient of the denominator. So bottom line of this, the idea is looking at the original, okay, if I combine these, the denominator would be x squared. If I combine these, the denominator would be x squared. The denominator would be x squared. So this would stay the same. This would be x squared. So we'd have to multiply the top and the bottom by x. So this would be x over x squared. So we'd have x minus 1 over x squared if I combine the two. Bottom line is we have an x to the first power over x squared. So the degree of the denominator is bigger than the degree of the numerator. Therefore, we have a horizontal asymptote at y equals 0. We have a horizontal asymptote at y equals 0. So if we look at the graph, notice that the graph gets really close to y equals 0. This would be y equals 0, the x-axis, but doesn't touch. And then the same thing on the other side. It gets really close to y equals 0, which is the x-axis, but doesn't touch. It can cross, which it crosses here, it's okay, but there's a horizontal asymptote at y equals 0. So in summary, for this problem, we have an x-intercept at 1, 0. We have an absolute max at 2, a fourth. We have a vertical asymptote at x equals 0. We have a horizontal asymptote at y equals 0. And we have an inflection point at 3, 2 over 9. So when we analyze a graph, we go through all 5 sections. Thank you.